Okay, so I've had 10 requests to work out a video solution for homework set number 3, Ohanian 4.90. This is the problem where you have a ferry boat on a river and it's traveling either directly across and back or up the river and down, and you ask for the time for those two options. So let's start with part A, where you're trying to travel across the river and back. Now, you're given the width of the river. D equals the width of the river. You're asked for a time. So let me just point out now that the connection between velocity, time, and distance is v equals d over t. And so that means that we want time, which is distance over velocity. So given distance d of the river, if we know the velocity and the directions we're traveling, then we can easily work out the time. Now, unfortunately, Ohanian uses this notation that I don't like, so I'm going to do some conversions of that. He says that the speed v is the velocity of the ferry boat relative to the water. I distinguishes that from the other velocities by capital or small letters, italics, etc. But let's make it very clear. This is the velocity of the ferry with respect to the water, or v ferry with respect to water. And I'll just use VF. I think that's clear enough. And we have some general idea of the direction. If we assume that the water is flowing towards the right, this is the water, or the currents to the right, then the ferry is going to have to head slightly upstream so it can make it directly across and directly back. So I'll be using something like this for my velocity vector for that. Now, the other term he gives you is the flow of the river with respect to the ground. He calls that a capital V. But I think it'll be clearer if I just call that the velocity of the water with respect to the ground. The velocity of water, ground. Now, I chose up above to make the water to go to the right. That's arbitrary. You could make it go to the left or any other direction you like, although left or right are the easiest things to deal with for now. So the velocity vector I drew up here actually is the one we want, because I'll assume that this is v water ground. Okay. Now, what we need in order to plug into the time formula is the velocity of the boat and the direction, or the ferry, directly across the river. So what we need is the velocity of the ferry with respect to ground and the direction straight across. Let me write that out. Velocity of ferry, ground. And that has to be straight across, perpendicular to the water flow. So that'll be ferry ground. We'll be in that direction. Okay. So given these two vectors, how do we find the magnitude of this vector? We already know the direction. Well, this is where you go back to my vector addition formula, or relative motion formula, where I say if you want the velocity of the ferry with respect to the ground in terms of another frame of reference, you can insert that other frame of reference in here. Just insert a pair of W's, and then we can convert VFG into velocities with respect to the water. So VFG is equal to VFW plus VWG. And if you don't understand where this came from, go back to the lecture notes and review how in 1D I talked about a police car and you, and that was very easy, I think, for most people to see how to do this in one dimension. And all we're doing now is saying, okay, 3 dimensions, no problem. Now, in terms of the vectors, the velocity of the water with respect to ground looks like this. The velocity of the ferry with respect to water must look like that if we're going to end up with the velocity of the ferry with respect to ground being perpendicular to VWG. So we're in luck. We have a right triangle. That'll make life easier for ourselves. Here you see VWG plus VFW adds up to VFG. Okay, those two vectors add to the third. Okay, we don't really care about the vector itself. We want its magnitude. We already know the direction. So we're after the magnitude of VFG. But we're lucky we have a right triangle, so the square of the hypotenuse equals the sums of the squares of the other two sides. Or the magnitude of this is the square root of the hypotenuse squared, VFW squared, minus VWG squared. Just Pythagorean's theorem, solving for this side given the hypotenuse and that side. Okay. Now we can just basically write down the answer. Okay? The time is going to be d divided by this magnitude, VFG, divided by this magnitude, but that's to make it in one direction. You have to do something similar when you come back, so this will be 2D to go across the river and then back again. So that's 2D. Now I just want to divide by this term, but I'm going to translate back into Ohanian's notation so it matches his answer. VFW, we've got the square root first. VFW is just the small v squared, and V water ground is just his big V squared. And that's what he tells you to prove, and we've done that. Okay, now let's go to part B, where instead of going across and back, the ferry boat goes up river. Well, upriver is, remember, opposite the current, and then back again. Okay, so if the current is in this direction, is capital V equals V water ground. Okay, so this is the direction of downriver, current helping you. When you're going upriver, okay, when you're going upriver, the velocity up will be equal to your velocity in the ferry with respect to the water. So that's going to be his small v minus the velocity of the river, which is fighting you. So your velocity will be smaller. If you like, I can write that as v up river will be equal to the v of the ferry with respect to the water minus the velocity of the water with respect to ground, because going upriver, the water slows you down. So this will give you the velocity of the ferry with respect to ground, or v up. And the subtraction comes from the direction of the two vectors. Okay. Meanwhile, v down, the current is helping you, so there's a similar, except it's little v plus capital V, or these two terms plus instead of subtracted. Okay. So those are the two velocities. Now we have to figure out the times to go both up and down river. So let's do that. The time to go upriver, just the distance you travel divided by v minus capital V. Okay. The time to go down will be equal to d divided by v plus v, and the total time will be equal to t up plus t down, which is equal to the sums of these two terms, d v minus capital V plus d times v divided, or plus capital V. And now I have to do some math to get it in the form that Ohanian has. Let me get another piece of paper. Okay. And this is the correct answer, but it's not in the form that we're trying to prove. So how do we get it into that form? So to do that, hopefully you remember from your algebra, I'm going to multiply this by v plus v, and I'm going to multiply this by v minus v. Then what I've got is a total time equals, well, this makes both of these terms here the same. When you do this multiplication, you'll have little v squared minus capital V squared for both of these. But to do that, I have to multiply this d times v plus v, little v plus capital V. And I have to multiply this d times little v minus capital V. Okay. So now I just simplify this expression. And what I'm left with when I add this up, well, I have a 2dv, vd plus vd, small v, but this term plus v and minus v, these will cancel, so that goes away. So I have 2vd over little v squared minus capital V squared. Okay. This is the time if you're going upriver and downriver. Okay. So now the question is, which trip takes a shorter time? So we have to compare this time to that time. This might not be obvious, so let me just do a little bit of math for this. Let's just compare the time to go up, down, compared to the time to go across. And if this time is bigger than 1, then this takes longer. If it's smaller than 1, then this is shorter. So if I do this, okay, what I've got is 2vd divided by little v squared minus capital V squared times, now this I have to take the reciprocal of that because I'm actually dividing by that. Okay, so it's times the square root of little v squared minus capital V squared over 2d. Let me simplify that. I can simplify that. The d's cancel, the 2's cancel, and I'm left with little v times the square root of little v squared minus capital V squared over little v squared minus capital V squared. Okay, well, square root of something divided by that something just gives you the square root of that something. So this is the square root of little v squared minus capital V squared. Now, we know that little v has to be greater than big V. Your ferry boat better be able to go faster than the current, otherwise you can't make the trip. So given that this is true, okay, that tells us that v has to be greater than v squared minus script v squared. Okay, well, we know this is true in any case because you're subtracting something from that. Okay, and so that tells us that this time, this relative time to go across, t up, down, divided by t across, must be greater than 1. So up, down is longer. You'll get across the river and back faster than if you tried to go up and down. Done.